In this video, we're going to look at an example of doing integration using partial fractions, where all the factors of the denominator are distinct linear factors. So let's say we have the integral of y over the product of y plus 4 times 2y minus 1. So since we have distinct linear factors in the denominator, we know that the partial fraction decomposition will be a constant over y plus 4 plus some other constant over 2y minus 1. I should also mention that, of course, the first thing we need to check is make sure that our integrand here is a proper rational function. This one pretty clearly is, because the degree of the numerator is 1 and the degree of the denominator is 2. So we don't need to worry about doing any long division things before we start. Okay, so our next step here after we've written out the general form of the partial fraction decomposition is clear our fractions. So multiply both sides by y plus 4 times 2y minus 1. So we've got y equals a times the quantity 2y minus 1 and b times the quantity y plus 4. This is a statement about polynomials, so this statement has to be true no matter what we plug in for y. So if we plug in y equals net 1/2 in this case, that'll cancel out that first term with the a in it. We can figure out what b is. And then we plug in -4 for y, we can cancel out the b term and we can figure out what a is. So plugging in 1/2, we'll get the equation 1/2 equals 9/2 b. And if we solve for b, we'll get 1/9 in that case. We put in -4 for y, we'll get -4 equals -9a, and so a will be 4/9. So our partial fraction decomposition then is 4/9 times 1 over y plus 4, and 1/9 times 1 over 2y minus 1. So putting that in for our integrand, we're now able to do the antiderivatives. Antiderivative for 1 over y plus 4 is natural log of y plus 4. Antiderivative of 1 over 2y minus 1 will be natural log of 2y minus 1, but we'll need to adjust for a 1/2 for that 2 that's on the y, so we'll get a 1/18 out in front as our constant.